Now we're going to explain the fundamental theorem of calculus and limits with Riemann sums. The idea of the area of a region being the limit of a Riemann sum comes from the fact that as the number of subintervals in a Riemann sum increases, so does the accuracy. If the number of subintervals is increased to infinity, denoted by the limit as n approaches infinity, the summation will yield the actual area under the curve of a function, not just an approximation.
But you're recording something.
As the number of rectangles approaches infinity, the sums of areas of the rectangles approaches the area under the curve. This is called the fundamental theorem of calculus.
Alright, so here we have a definite integral. So get x to the fourth over 4 from 1 to 3. And move this over. So that would be 3 to the fourth over 4 minus 1 to the fourth over 4. And let's see, 3 to the fourth is 3 times 3 is 9, times 3 is 27, 54, 81. So 81 over 4 minus 1 over 4, that's 80 over 4, which equals 20. And there you go. Okay, so definite integral, so you take the antiderivative, which is x to the third over 3 plus 2 x to the 2 over 3 from 0 to 1. So you go down. It's 1 to the third over 3 plus 2 add 1 to the third over 3 minus 0 to the third over 3 plus 2 rad 0 cubed over 3, which is, oh sorry, parentheses, which is just 1 over 3 plus 2 over 3 minus 0, which just equals 1. There you go. Okay, so for this problem, you have to find the position, which is the antiderivative of the velocity. So you have your initial condition, which is -2. And then you have to do a little bit of, I guess you could call it u-substitution to get the coefficient of the antiderivative, which is just going to be the reciprocal of the coefficient in the argument, which is 6 over pi, and then times the antiderivative of the velocity, which is going to be sine pi over 6t, evaluated from 0 to 4. So you do -2 plus 6 over pi times sine of 4 pi over 6, which is sine of 2 pi over 3. Minus sine of 0 pi over 6, which is sine of 0. And then, so sine of 2 pi over 3, that's in the second quadrant, reference angle pi over 3, so it's positive, and sine of pi over 3 is rad 3 over 2. So you get, let me zoom in a little bit here, you get -2 plus 6 over pi times rad 3 over 2 minus, let's see, so sine of 0 is just 0, so minus 0, so I guess we'll just put a parentheses there. And then you multiply that out, you get negative 2 plus 6 rad 3 over 2 pi. And if you want to, I guess you could leave it at that, but I'll just go a little further here. Multiply, get a common denominator, which would be negative 4 pi plus 6 rad 3 over 2 pi. And if you want to simplify that even further, you can factor out 2, and you get 2 times negative 2 pi plus 3 rad 3 over 2 pi. 2's cancel, which gives you your final answer of 2 pi plus 3 rad 3 over pi. Here you go.
You would have just simplified.
So
it.
sorry,
Like
guys.
C4 and then-
Forgot the negative. There we go.
Is that going to be in the video? Congratulations! You've mastered the fundamental theorem of calculus. Yay!